Good afternoon, everyone. This is Praveena, Avanti Institute of Engineering Technology, Department of EEE. Welcome to all the participants for the day 5, that is last day of our 5-day FDP development program, faculty development program. So it's my pleasure to introduce our esteemed resource person, Dr. Venkatramana Veramsetti, received ME degree from University College of Engineering, Osmania University in 2011 and PhD from NIT Warangal in 2008. He had 10 plus of years of experience, teaching experience, and also worked as systems engineer at Infosys during the period from 2011 to 2013. Currently, he is working as associate professor in the Department of CS and AI and as a director of Center for AI and Deep Learning in SR University, Warangal. He received NVIDIA Deep Learning Institute Ambassadorship in 2018 and continued as official NVIDIA DLI instructor from 2018 to 2020. In this, he conducted various workshops in Telangana and Andhra Pradesh and trained around 300 plus students on deep learning techniques using NVIDIA cloud GPUs. Also, he trained 500 plus students on Microsoft Azure AI certifications. He published more than 10 SCI papers and more than 30 Scopus articles in various research areas like power systems deregulation, power system optimization, and AI applications in electrical engineering. So today's topic is EV charging management using deep learning. Thank you, sir. Thank you for accepting our invitation and welcoming you, sir.
Thank you, madam. Can you please confirm my voice is audible?
Yes, sir. Audible, sir.
Yeah, thank you.
Okay.
So, first of all, thanks to Avanti Institute for giving this opportunity to serve the resource person in this 5 days FDP program. And also, thank you, Praveena madam, for your nice introduction. So, I hope and continue, hope that my voice is clear and audible to all of you. In the next 2 hours, I am trying to present one of my work, that is EV charging management using deep neural networks. Let me share my presentation. So hope this screen is visible to all of you. So the next 2 hours, I'm trying to explain the EV charging management using the deep learning techniques. And in this study, I used deep neural networks. So by using the deep neural networks based on the electricity price forecasting, so we are suggesting few charging strategies. That means whether we are going to go for the grid to vehicle strategy or vehicle to grid strategy, or we are going for the only grid charging. So 3 modes of charging management we calculate. So one is called grid to vehicle. That means we are going to charge the battery, or vehicle to grid. That means we are providing the power to the grid, that the vehicle to grid mode. And normal discharging mode, that is during the running condition of your electric vehicle. So what is the suitable strategy? Based on the few parameters like P by M ratio, that is called as price by mean price ratio, and battery level, and what the present state of the vehicle and what will be the next state of vehicle. So state of vehicle, again, it is mentioned in the 2 ways. One is present state may be like 0 means it is a running state. 1 means it is a parking state. So those the notations we consider in this project. So 0 means it is a running state, that means vehicle is in the running mode. One vehicle is going in the parking mode. So let me go inside. So this is the my outline of presentation. First, I am trying to give some introduction about the charging management and a problem statement and about the objectives in the block diagram, in the methodology, and some other discussion I am trying to explain. Coming to the introduction, the rapid adoption of electric vehicles, it presents both opportunities at the same time challenges also. Whenever there's a new era is coming, so there is a more number of opportunities at the same time there are the challenges also. While grabbing the opportunities, we have to face the challenges also. We have to provide the solution for the challenges also. So one of the critical aspect or critical challenge of optimizing the EV adoption is efficient management of EV charging. The efficient management of EV charging. EV charging means, so when we are going to charge our electric vehicle, when you are going to sell the power from the electric vehicle to the grid, assuming that you have a surplus power, you have the better capacity. So based on the electricity price dynamics and the grid stability. So based on what parameters we are considered to justify which charging strategy is suitable, whether you are going for the grid to vehicle or vehicle to grid, which will be the suitable strategy for a particular time interval. That can be decided based on the two parameters. One is called the electricity pricing dynamics, electricity pricing at that moment, at the same time grid stability. Whereas in this, in our work, and also in this presentation, I'm trying to address electricity pricing dynamics, not respect to the grid stability. So if anyone want to work in that direction, it's a more welcome. So that means electric vehicle charging management based on the grid stability. But here we consider only electricity pricing dynamics. The cornerstone of this presentation lies in the seamless integration of artificial neural networks or deep neural networks for electricity price forecasting. And again, we are using the deep neural network for EV charging recommendation in response to the forecasted price fluctuations. Based on the forecasted price fluctuations, what we are going to suggest, which charging mode we are recommending. So that also we are working in this presentation. So what I mean to tell is, so in this work or in this presentation, we use the two deep neural network models. One deep neural network model is used to forecast the price, estimate the price for the next 15 minutes. And based on the estimated price, another deep learning model will suggest, will recommend for the next 15 minutes, which charging mode will be the better based on the previous neural network forecasted price. Okay, let me explain in detail about this one. So here we are developing the two deep neural network models. So one deep neural network model is used for the price forecasting. So based on this price forecasting, we are developing another deep neural model. So we are taking this forecasted price as one of the input feature for my second deep neural network model. And this deep neural network model will suggest which type of charging mode we are going to, whether it may be a grid to vehicle, that means 0 means grid to vehicle strategy, or 1 means it is a vehicle to grid strategy, or 2 means it is a discharging mode. So don't confuse why I am saying that 0, 1, 2, all the things, because whatever the most deep learning models or machine learning models we are implementing, that we are implementing as a computing. So computer is able to understand only numbers, right? So because of reason, if there is a G2B mode of recommendation, then it will give us input as a 0, output as a 0. If the neural network giving the output as a 1 means it is a vehicle to grid mode. If the in order to give the output as a 2 minutes, it is a discharge mode. So these are the 3 recommendations. So that will be given by this proposed methodology. So until I'm trying to convey one thing, that is we are trying to use the two deep neural network models. One neural network model is used for the price forecasting, another neural network model is used for the recommendation. So which type of recommendation we suggest? Now coming to our presentation. So the increasing adoption of electric vehicles presents growing challenges, as I said earlier, for electricity grid management due to variable demand for the electricity price during the charging period. Dynamic electricity pricing mechanism, such as time of use, that means at what time we can go for the EV charging, at what time we are going for the vehicle to grid mode. So that the time of use rates and offer cost saving opportunities for the EV ones. So we have to provide that information. If you are able to provide the information to the EV owner, like, so at this time this will be the market price, at this time this will be the market price, they can decide. Or your model able to give some recommendation. Yeah, now the price is very high, so it's not a good time to charge your electric vehicles. Rather than if your battery level is good and you don't have any plan for the long journey, then you go for two V2G mode. That means you can connect your vehicle to the grid and you can sell your power. You can sell your power. For example, if the forecasted price is very less and you have a battery, still you have some chance of charge your battery. It's not a fully charged. It may be 60% charged or 20% of charged. Then there is a chance of charge your vehicle. Then your model will recommend you go for the G2V mode. You can connect to your grid and charge your vehicle. So based on the time electricity price dynamics, so you can recommend which mode, which strategy, which charging mode we can go for. Of course, now to forecast the price, it is something a complex problem. You need to deal with the complex patterns and the dynamic nature of the electricity prices. So to solve this problem, so deep learning is a good aspect, and deep learning is a good choice for the any parameter estimation. Here we are trying to estimate the electricity price. So here we are using the deep neural network for forecasting the electricity price. For forecasting the electricity price, we are going for the deep neural network. Now the objective, sir. First objective is develop. What we are going to develop? I want to develop a deep learning based model. So that is called deep neural network for accurate short-term price forecasting. I am taking the 15 minutes of origin. That means every 15 minutes I want to forecast the price. That means now the time is 2:15. I'm trying to forecast the load at the 2:30 p.m. later at 2:45 p.m. later at the 3 p.m. like that. For every 50 minutes of block, I am trying to forecast the load, and based on the forecasted load, I'm trying to give the recommendation for your EV also. The model will give the recommendation for the EV also. So this deep neural network model we are trying to develop, we are trying to build. We are trying to build the deep neural network model to forecast the electricity price for the 15 minutes origin. So that is the first objective. Once you developed most accurate deep neural network model in terms of mean square error or mean average error, then what you have to do? You are happy with your performance of your model, then you are trying to integrate. Now integrate the price forecasting model. You developed the deep neural network model already for the price forecasting. Next, what you have to do? Integrate. What we are going to integrate? Integrate your price forecasting DNN model. That's what we worked on in the previous section. So integrate the price forecasted model with another ANN or DNN model. So you can integrate this one with another ANN or DNN model. And this DNN model, we suggest the recommendations. Which type of recommendation, which type of charging mode we are trying to go, whether it is a G to V, or it will be V to G, or it may get rechargeable. We are trying to go for. So that means the whatever the DNN model which we developed for the electricity price forecasting, we are integrated with the another DNN model which is used for the recommendation and evaluate. So if you develop a particular deep learning model, then you say that you are doing a good job. If you say, if you build some DNN model and if you say you are developing a most accurate model, it is not a matter. You have to evaluate, you have to validate your developed models. Whatever the deep learning models you develop, you have to validate it. You have to validate it. You have to check the effectiveness of your deep learning model by comparing with the other methods. By comparing with the other methods, you have to evaluate. You have to evaluate. You have to validate your model by comparing with the other machine learning models like linear regression model or Bayesian tree model or random forest model or machine model. Any other machine learning models you can compare. So actually, this single block diagram will help to understand the whole work. Will help to understand the whole complete work of this presentation. Here, first I am developing a artificial neural network model or deep neural network model to forecast the price. It 15 minutes of origin. For every 50 minutes of origin, I am trying to forecast this. So now it is now it is 215. By 230, what will be the price? I'm trying to forecast now. And I have to give the suggestion to the electric vehicle owner. What will be the better choice of your usage of your electric vehicle in the next 15 minutes? Similarly, at 230, I'm trying to forecast the price for the 245. At 245, I'm trying to forecast the price for the 3 p.m. And at 245, I also give the recommendation. To the EV owner what strategy he has to go. He can go at 3 p.m. So I will forecast the price at the 2:15 p.m. now, and based on this one, suppose I will forecast the price at 2:50 m for the price at the 2:30. And based on this price, I am trying to tell which I am trying to recommend which mode of operation is better for him at 2:30. Similarly, at 2:30, I am trying to forecast the price for the 245. And based on this 245 price, I will give the information to the EV owner at 2:30. What will be the recommended charging strategy at the 245? So like that, for every 15 minutes, we are trying to feed the information to the EV owner. So now coming to this block diagram, so I have the first deep neural network model. This is used for the price forecasting. So I'm trying to forecast the price forecasting based on the total 98 input features. Based on the total 98 input features. Total 98 features means I'm trying to forecast the price at a particular time. I'm trying to forecast the price at a particular time based on the last 24 hours load price information. For the last 24 hours price information. That means 24 hours means every hour we have the 4 quarters, 450 minutes. So 24 hour means for every hour we have the 4 quarters. That means we have the 15, 13, and 45 and 0. So these are the total 450 minutes blocks. So 4 blocks. So that is the total 96. So these 96 last 24 hours as samples. Hope you understand what I mean to say. Let us assume I am trying to forecast the price at 2:30 p.m. now. Okay, 2:30. What the price at the 2:30 p.m. I am trying to forecast based on the last 24 hours. So last 1 hour means what will be the last 1 hour? Last 1 hour means you may go for the 2:15. So you may go for the 2 o'clock. You may go for the 1:45. You may go for the 1:30. So you may go for the 1:15. So this is a 150 minutes block, 50 minutes block, 50 minutes block, 50 minutes block, total 1 hour block. So 1 hour we have the 450 minutes block. If you go back to the 24 hours, how many blocks we have, how many samples we have? For every 50 minutes we got one sample. So if you go back for the 24 hours, so total number of samples, input samples we have, it is the 96 samples. So that's why then 96 samples, but here I am showing that 98. So in addition to the last 24 hours price samples with a 15 minutes block, plus two more features also we consider. Those are called as the season status. That means whether it is a rainy season or it is a summer season or it is a winter season. So rainy season we are referring to the 0, summer season we are referring to the 1, and winter season we are referring to the 2. Similarly, another feature is called as a day status. So day status means whether the day is a working day or it is a weekend. Working day or weekend. Okay. So if it is a weekend, then we consider a 0. If it is a working day, then we consider a 1. So like that. So total 96 plus season feature and plus day status feature, total 98 input features we consider to estimate or to forecast the price at a particular time, 2:30 or 2:45 or 3 p.m. like that. At any particular time, want to forecast, I am trying to take the last 24 hours price samples, we take 15 hours 15 hours block. Sorry, 15 minutes block. With the 15 minutes block. So that's a total of 96. In addition to that, we put the and two more input features that is called as the season and the vegetables. Fine. So this is the deep neural network model, which helps, which was trained, which was tested, and it was deployed to forecast the price based on these 98 input features. So this model will give the price information. This model will give the price information at 2:30 p.m. Let us assume. I'm trying to run this application at 2:15. At 2:15, it gives the information about the price, electricity price at 2:30 p.m. And same DNN model, same trained tested model, I'm trying to deploy here also. Same model I'm trying to deploy here also. But what it will do is, so I have to run this model before starting of the day. That means actually today will be starts at midnight or 12 o'clock, right? So before that one, around at 11:45 midnight of last night, midnight 11:45, I am trying to run this model for to get the price of next 24 hours. That means next 24 hours is today's 24 hours block, 24 hours region. That means last night 12 a.m. to today night 11:59 p.m. Up in that range. So I'm trying to, this model will help you to get the forecasted price at every inch of time. So total 24 into 15, that is a 96 predicted values will be coming from here. Based on these 96 predicted values, we are trying to calculate the mean value. That is, hope you understand. Just I am last night. Okay. Last night at 11:45, already these models are developed. Let's assume the models are trained and tested with the deployed. Now I am running this application. First, I am running this model at 11:45. In such a way that I have to write a program in the backend, such a way that this model will give the estimated price for the next day. That means today, from the 00 to 11:45 p.m. For every 50 minutes of block, we are estimating the price every 50 minutes of block. Now take the average of all those things. Take the average of those things. Okay. So let us do. I have the average value as a, for example, I'm saying. Example, let us do average value equal to megawatt. Okay. Now this model will be executed for every 15 minutes. So this will be executed once in a day at midnight 11:45. So it will give the whole predicted price for whole day. Whereas the first model, this one will be implemented, or it will be run for every 50 minutes of block. Now, when I run this model at the 2:15 p.m., it will give the information about the 2:30 p.m. price. Now, this 2:30 p.m. price, let us assume it is a 2:35 p.m. price equal to, let us assume 1 megawatt. Let us assume 1 megawatt. Then what is the P/M ratio? So my price at the 2:30 p.m. equal to 1 and mean value equal to 2. So 1 by 2. So P/M ratio equal to 0.5. So this is the P/M ratio. So this is the one of the feature for the another deep learning model or ANN model. I said two models I am using. One model for the price forecasting, that is information coming from here. From this information based on this mean value, I am getting the P/M ratio. And this PBM ratio is one of the input feature for the ANN model. For this ANN model, this is the PBM ratio, the one of the input feature. In addition to this one, we have the few more um, input features like what is the level of the battery, what is the present state, and what is the next state. So based on this PBM ratio, based on this battery level, based on this present state, and based on this next state, this deep neural network model, which it should be already trained and tested and deployed here, this will give the recommendation whether you go for the grid to vehicle mode or whether you go for the vehicle to grid mode or it will the discharge mode built in. So this is the whole thing, whole process of your methodology for this presentation. But how we train and how we test, how we collect the data, how we tune the hyperparameters, all the things we will going to discuss in the results section. So mainly I want to tell is I am developing two deep neural network model. This is the one, this is the two, and the same deep neural network model I am using in this case also to get the mean value. Based on this mean value and based on this forecasted value, I am getting the P/M ratio. And based on this P/M ratio, based on this battery level, based on the present state, and based on the next state, my deep neural network model will give the information about the recommendation, whether it's a to vehicle or vehicle to grid or discharging mode. As I said earlier, here the charging recommendation is based on the dynamic prices, not based on the stability, grid stability. So if anyone interested, you can move in that further direction. But in future, you can integrate your grid stability related also. Now, what are the steps we follow? Not only for this project, for any deep learning project, is the things we have to follow. Okay. So electricity price forecasting, what steps we followed is our first step is data collection. We follow the data collection first step. So we collected this data, we collected the data for every 15 minutes block from Indian Energy Exchange IEX. From IEX, we are collecting the data. So for the period, you can see here. Yeah. So we are collected the data from the Indian Energy Exchange from the period to January 2022 to 30th January 2022. With the 15 minutes block range. For every 15 minutes, you can see so this is the 15 minutes block, this is the price, and this is the next 15 minutes, this is the price, next 15 minutes, this is the price, next 15 minutes, this is the 1 hour. And like a second hour, 4 quarters, third hour, 4 quarters. Like that, we collect the data from the exchange. So that will be the first step. Not only this one, if anyone working on any machine learning or deep learning related projects, so your first step will be data collection. You have to collect the data collection. So we collect the data from the Indian Energy Exchange with 50 minutes of block. Okay, this was completed. So after the data collection, there is a one more step we have to do that is called as a data preprocessing. We have to call it as a data preprocessing. So here we use the data normalization and the data split. And in addition to the data normalization and data split, we have the missing value treatment and the outlier treatment also is there. So missing value treatment means in your data, where you are collecting the data from source, there is a possibility of missing of some data. Some cells may be empty. So with that data, you can't train your model. It will throw an error. So then, before feeding your data to any deep neural network model for training and testing purpose, prior to that, you have to check whether there is any missing values or not. If there is no missing values, it's fine, no problem. But if there is an missing value, you are going for the imputation. So there are different types of imputations techniques are there. Missing value treatment are like removal of row strategy, removal of row, replace the empty cell with the mean value of the feature, replace the cell with the median value of the corresponding respective feature. So like that, there is a different strategies are there for the missing value treatment, but I'm not trying to go in detail all these things. Similarly, there is the outliers. Like outliers means generally, if you have a particular feature, that particular feature have a some range. Let me give For example, I'm saying, let's assume you are developing an application for the COVID prediction, COVID diagnosis. And one of the features for the COVID diagnosis, you are considered as a fever. So the fever values corrected data is like maybe 98.6, 92.3, and 101.2 and 107.8. Sorry, I'm sorry. So not 107, let us do it is a 1002 and something like a 99.2 like that. So if you see this favor feature, this will be the odd value, not in the normal range, abnormal range. The abnormal value, not a normal range value for a human temperature. Human temperature is around 100 degrees Celsius, right? But 1002 is not like this. So that type of samples are called as outlier samples. We have to do something outlier identification and also outlier treatment also we have to work on it. Okay, but fine, we're not going in detail. And just I'm trying to tell what are the different data pre-processing techniques we have, like missing value treatment, outlier treatment, data normalization, and the rest. So data normalization means we are trying to normalize the data between the 0 to 1. We are trying to scale down the data between the 0 to 1. For example, why we applied data normalization means, for example, I want to tell one small thing like there is a one some organization, and in the organization, majority peoples are there. Is some majority section of peoples are there, and minority section peoples are there. And if this organization trying to take some decision, then the decision definitely will be influenced by the majority people. These majority people, there is a possibility. There is a possibility that the decision taken by the organization may be influenced by the majority people because they have a large number. Okay, so that means your decision will be influenced by the majority people, right? Definitely, you have to agree actually. For example, you have an organization where many people are coming and a few people are from the some other regions and few people are the most of the people are the local region. So whenever some decision we have to take care, that decision should be satisfied with majority people. That means these people will decide your outcome of your organization decision. I'm not saying always, there's a possibility. Like that, in case of the machine learning also or deep learning also, if you see the CNN model, it has the 96 price values. The price values are in terms of the thousands. And where is the two more features? One is called as a season and this is called as a day status. So day status is the 0 and 1 and season status is 0, 1, 2. You can see here. So these values are very high. The price values are very high values, where the season values and day values are very small. So there is a possibility the outcome of your NN model will be highly influenced by your majority values, load values. Okay, and they may be against your small features. To avoid this type of problem, try to scale down all the features in the range of 0 to 1. That is called as the data normalization. That is called as the data normalization. So actually, we use the Python Keras deep learning framework for the deep learning actually. But in case of MATLAB, we can write a code also. We can write a code to build the deep neural network, and also we have the many tools also for the LSTM, RNN, CNN also in the MATLAB. We have the tools. You can write a code in the MATLAB to build a deep neural network model or to build any CNN models. Or if you are not good in the programming, we have a NN toolbox like NF tool, NN tool, and also we have the CNN toolboxes and we have the LSTM toolboxes. You can go with toolboxes. So generally, we will prefer toolboxes if you are not familiar with the programming. Moreover, really, as we are faculty, I am suggesting try to understand the mathematics behind every deep learning model or machine learning model and try to write a code by yourself to implement it, then it will give some more confidence for this. If you go for the toolboxes, it's like a black box. It's like a black box. That means you don't know what is happening behind. So as a faculty, my suggestion is to go for the scratch, but not at least at the time of learning for small applications. Of course, as in a big application, it's very difficult to write a code from the scratch. For a deep neural network, for a very deep convolutional neural network, it's very difficult to write a code from the scratch. Then you can go for the libraries or you can go for the toolbox. But at the time of learning, I'm suggesting to try to learn the mathematics behind every model. Try to write a code for a very small problem. For a big problem, you can't write a code. It is difficult again. So write a code based on your understanding, based on your understanding the mathematics. Write a code by yourself for a small applications. Then you can understand what happened behind. Then you go for the toolbox because you already know what happened inside your toolbox. If you directly using the toolboxes means personally feel that it's like a black box. Just we are feeding the data and seeing the output. So you have the toolbox in the MATLAB for a deep learning. And another is called as the data script. Data script means what we are see. Suppose when I am going to my class, I am teaching one unit. I am teaching one unit. So in this one unit, I am preparing the 10 questions. Out of 10 questions, I will explain only 6 to 8 questions in the classroom during the training phase. Whereas out of 10, remaining 4 to 2 questions I will keep aside, and I want to give these 2 questions in the examinations to evaluate my students' performance, to test my students' performance. That means whatever the data I have, whatever the questions I have, whatever the materials I have, I'm splitting few questions for the training purpose and a few questions for the testing purpose. Here also same thing. Whatever the data we have, so out of this data, we are splitting the data majorly likely for the training purpose and for the testing purpose. That is called as the data split. So data split is nothing but the splitting the whole data for a training purpose and the testing purpose. Make sure that there are no duplicates between the training and test data. Make sure there is no duplicate between the training and testing the data. Training data, testing data, there is no duplicates. And you have the huge amount of data is required in the training and less amount of data is sufficient for the testing. When training, we require more data, right, to train the students. At the time of testing, we may give 1 or 2 questions. That's sufficient. Similar in the AI also, the deep learning or machine learning also, we have to split the whole data into training and testing. The training data should be large data. Testing data is a small data. And this training data is used to train the model. And with the testing data used to test the model after test training. So that is called as the data split. So after this data pre-processing is completed, then you are going for the model development. So you can take one deep neural network model and feed this training data and choose proper optimizer and train your deep learning model. You may go for program from scratch, or you use any toolboxes, or you can use any libraries. Okay, so any of them, you can write your own code, or you can use any toolboxes, or you can use the libraries, and you need to train the deep neural network model based on this training data. That is called as the model development. Once the training is over, so what we will do? So if the training was completed in our classrooms, during the semester the training was completed, we will do the grade report directly. We will pass all the students after training. No, we are going to evaluate the student performance. We are going to test the student performance, right? So that is called as a model evaluation. So for the model evaluation, what we are going to do? So using this test data, we are going to evaluate the model. During the training data, with the training data, we are going to training data is used for the model development, and this test data is used for the model evaluation. So suppose if you are happy and if your client also happy with the performance of the model during the training, that means during the model development, and during the testing, that means model evaluation, in the both training phase and testing phase, If the performance of the model is good, then you go for the model deployment. You go for the model deployment. So model deployment can be done in the back end of any application. So is the front end. In the back end, you are going to deploy this model. And the front end, you are giving the some information, and that information is going to your back end model. It will process and it will give the output on the front side again. It will give the output to the front side again. So this is what happened in the model deployment. So major parts. So same thing I am using in the EV charging management also. This is another deep neural network model or ANN model, right? Same strategy I am applied for the whatever the strategy I am applying for the electricity price forecasting. Same strategy is used for the electricity charging management also. For this deep neural network model also, same strategy I am using. What strategy I am following for the price forecasting. So finally, what are the major steps in any deep learning project is one is called as the data collection, another is called as the data pre-processing, and another is called as the model development, nothing but the training model development, and this is called as the model evaluation, nothing but the testing. So if you are happy with the model development and model evaluation, otherwise you have to do this model development and evaluation repeatedly by changing the parameters of a model, by changing the hyperparameters of a model, like number of hidden layers, like number of hidden neurons, like activation functions. By changing these the type of hyperparameters, you can retrain the model and retest the model until the performance is satisfied by you and also by your client. Once your errors are less, you are happy and your client is happy, then you go for the last phase that is called as the deployment. You have to deploy your trained DNN model in the back end of our any application. If it is the front end and the back end, you have to keep the deep neural network model. From the front end, we will feed the data, and the data is given to back end deep neural network model. Inside the deep neural network model, some mathematical operation will be going on, and based on this mathematical operation, your output will come forward, and that will be again displayed on the front page. So this deep neural network model will be not only deep neural network model, any DL model, any deep learning model is deployed in the back end of your application. Okay, so this is what complete pipeline of any machine learning or deep learning project. Now, so coming to the first phase, that is called as the data collection. As I said, the data is collected from the Indian Energy Exchange for every 50 minutes of block. You can see every 50 minutes of block from the period 1st January 2022, 1st January 2022 to 30th January 2024. So the total data is observed. In these units are the Indian INR per megawatt hour. This is the INR per megawatt. This is the INR per megawatt. Fine. We collected the data. So we collected the data like this. I have collected the data like this. Then what I have to do? What I have, I collect the data like this. What I have to? Next thing is a data pre-processing. Next thing is a data pre-processing. So data pre-processing, your first step is feature selection. I forgot to mention. First step is feature selection. So feature selection means what are your input features? You have to keep it in a proper order. So what are the input features? Total 96 price samples with 15 minutes of block. With 15 minutes of block, total 96 of price samples. Okay, so that's what can be. The features are previous 24-hour electricity prices, which are divided into 96, such that every 15 minutes range you have to take the price value. 24 hours is 24 into 4, so total is 96. In addition to that, one more feature that is called as season, and in addition to that, one more feature that is called as the day step. So total 98 input features are taken. So how we got this data? You have to write a small code. Actually, we have a data in a like a column matrix, but we have to prepare data like this. So we have to write a small code. We have to rearrange it. We have to rearrange the data such that so F12 feature 1 F12 F96, that is the prices. 96, that is the prices, and F97 is a season, and F98 is a your data, and last column is a your price column. Last column is your price column. That price you are going to predict. That price you are going to predict, or the price you are going to estimate. That is called as the target variable. So this is called as the target variable. And whereas F12 price, F1 to F98, that's the F1 to F96 previous electricity prices, F97 season value, F98 day status value. So these all are called as the input features. 96 plus 2, that is total 98 input features. And last column, price column, is called as the target column. But of course, in this screenshot, you are able to see up to 13 features because I can't accommodate all 96 plus 2, 98 plus 1 target column. That means almost 100 columns in a single slide. Just for understanding purpose, for the illustration purpose, I kept only 13 columns. So once the data pre-processing is completed, so next step is data normalization, as I said earlier, and we have to keep the data split also. Data normalization and data split also. So in the data normalization, as I said earlier, so data normalization is nothing but that you are going to normalize the data by using between the range of 0 to 1. So if you are using you can write a code by yourself to normalize the data. Generally, the formula which is used to normalize the data is x minus x minimum divided by x maximum minus x minimum. X is the actual value, and if you want to calculate this normalized value, it's normalized value x norm. If you want this x is the actual value, if you want to calculate its normalized value, then you have to use this formula. X is the actual value minus minimum value of the x feature, maximum value of the x feature you have to keep. For example, let's assume here is the feature x has a value 4, 5, 3, and 2. Let's assume. Then what is the corresponding normalized values? So first, x value 4, right? So 4 minus what the x minimum? Against this, what is the minimum value? 2. 4 minus 2 divided by what is the maximum value? 5 minus 2. So 4 minus 2, 2, and 5 minus 2, 3. So 2 by 3 means it is around 0.6. So this is the value 0.6. If it is a 5, then the output will be 5 minus 2 divided by minimum value, 2 divided by maximum value, again 5 minus 2. So this one is going to cancel, this value equal to 1. And if you see this one 3, then you have the x minus x minimum 2, x maximum 5, x minimum 2. 3 minus 2 means 1, 5 minus 2 means 3, 1 by 3 means it is a 0.3. Similarly, if you go for this one, so minimum value is the 2. Minimum. Okay, 2 minus minimum value is 2 divided by maximum value is 5, minimum value is 2, so it will be equal to 0. This will be equal to 0. Like that, whatever the values, all the values are, we are going to scale down between 0 to 1. That is called as the normalization. For this process, you can easily write a code using either Python or MATLAB. If you're not interested, if you're not comfortable in the programming, in the Python, there is a library called MinMaxScaler. MinMaxScaler. So using this library, you can easily normalize the data. You can easily normalize the data. So once the normalization is completed, next part is called as the data split. Once the normalization is completed, next part is called as the data split. So in the data split, you have to split the data, 80% of data for the training and 20% of data for the testing. Can use 80% of data for the training and 20% of data for the testing. As I said earlier, so you have to keep the huge amount of data for the training purpose, whereas the less amount of data is sufficient for the testing purpose. Okay. So based on our process, first data collection, later feature engineering, feature selection, later data normalization and data split. And actually we have to go for the missing value treatment, dotlet treatment also, but I'm trying to omit it, but we have to do that also. Now, what will be the next step after completing the data collection, data pre-processing? Next one is the model development. So model development is the model development. So what we are going to do in model development? So the ANN model is trained. The ANN model is trained based on the pre-processed data, load data, by splitting the data for the 80%, 20%. But means with 80% of data, we are going to train your deep learning model. With this 80% of data, we are going to train the deep neural network model. And remaining 20% of data is used to test your model after training. To test your model after training. we developed a model by tuning the hyperparameters, because whatever the model we are getting, we can't say that is the best model. We have to play with its hyperparameters. We have to tune the hyperparameters, like number of PD layers, number of PD neurons, and activation functions, and optimizers, and batch stages, iterations. All this you can play and try to get the optimal deep neural network model. Optimal deep neural network model is that has the lowest errors. That has the lowest errors. So best optimized value or best optimized deep neural network model is nothing but the less mean square error model. The model which has the lowest mean square error value, the least mean square error value, that is considered as the optimized model. That optimized model is going for the model evolution. The model evolution. In the model evolution, we are going to use the 20% of data, separated data for the testing rate. 20% data already separated for the testing purpose. So based on this testing data, we are going to test your model. The model is already trained here, and now we are going to test your model. In the testing also, again, we can go for the mean square error, or you may go with the mean percentage errors. Mean error, any error you can consider. These errors are less both in development phase, training phase, and evaluation phase, testing phase. Then you go for the real-time deployment of your model. Real-time deployment of your model. Okay. So this is the process what we followed for the electricity price forecasting. And whereas another deep neural network model also available, right? Another deep neural network model also is available. To the deep neural network model, also same process. You have to collect the data. You have to select the features. You have to normalize the data if required, and you have to split the data. You have to train the model. You have to test the model. If you are happy with your training performance and testing performance, then go for the real-time deployment. So in the second DNN model, we consider the four input features. One is called as the price to mean value, BL, battery level, present state, and next state. So present state 1 means it is called as the parking. Next state and the present and state 1 means it is the parking, and state 0 is nothing but the running state. It is the running state. Okay, it is a running state. So these are the four input features we are considering to train the second deep neural network model for the recommendation. And this last column REC, that is called as recommendation column. This column is called as the target column or called as the target value. So this column will tell you what is the recommendation strategy, what is the recommended strategy, what is the recommended charging strategy. Whether you go for the grid to vehicle charging mode, or you go for the vehicle to grid selling mode, or you are in the discharging mode, vehicle running condition. So that three type of recommendations will become. Those values are available in the last column, that is called as the target column. Here only I took only top 5 samples. That's why only zeros are showing, and there is a remaining samples also available with values 1 and 2 of. So coming to here, the features like P/M ratio, this one, and the battery level, this one, and the present state, this one, and next state are used to get the recommendation for the charging. What type of charging we may go for? What type of charging we may go for? That we go for discharging mode, we go for the grid to vehicle, go for the charging. But as I said earlier, so whenever there is some like in your data you have some like words, so then you have to convert into numbers. That is the reason why in the last column you are able to see 0. That means if it is a discharge, so if it is a grid to vehicle mode, it is a 0. If it is a V2G mode, it is a 1. If it is a discharging mode, then you can call it as a 2, 0, 1. But in case of the multiple classification, like this, the multiple classes, 0 class, 1 class, or 2 class, or G2B class, V2G class, or discharge class, you have the multiple classes in the output label or output feature or target variable. Then you are going to go for the dummy coding. Dummy coding means, so 0 is a G2B, right? So G2B. So whatever the REC variable is there, recommendation variable is there, it has the 3 values, whether it may be a G2B, or it may be a V2G, or it may be a discharge mode, right? Suppose some particular input feature saying that G2B, then under the G2B you have to keep 0, remaining all you have to keep 0. 1. Under G2 you have to keep 1, remaining all you have to keep 0. Suppose if any strategy is suggesting that it should be a V2G mode, then G2B and discharge should be 0, V2G should be 1. So this type of numerical conversion, number conversion is called as the dummy code. So actually if you observe here in REC, you have the only one column. It has only 0 values. If you go further, you have the 1 and 2 also. Now I am trying to this column into the 3 sub columns. I want to convert this single column into the 3 sub columns. You can see the output. So PM, price to mean value, battery level, present state, next state, and whatever the REC recommended system, you are splitting into 3 categories. REC 0 is nothing but the G2B, REC 1 is nothing but the V2G, and REC 2 is nothing but the discharge. Right? So G2B means only G2B column only 1, remaining all are zeros. You can see here this these features will say suggesting that you go for the discharging mode. You go for the discharging mode. You can see here you go for the discharging mode 1. Why here 1? The third column is the 1. That means discharging mode is 1. Discharging mode is 1 means it is suggesting discharging mode. So in between you can some other if you go further some values against the REC1 V2G also some value as 1. Suppose this value is 1. Suppose I'm saying some value is 1 here. Then this combination saying that we go for the V2G combination, V2G recommendation. So like that, dummy coding will work. The dummy variable creation will work in case of the multiple classification. Multiple classification. I think you are able to understand how we are going to use the dummy coding. Okay, that means actually target variable we have the only one column REC, but we are splitting into 3 columns. One is the 0 column, 1 column, and 2 column. That means with the 0 number, with 1 number, and 2 number. So 0 means it is a G2B, 1 means V2G, and discharge 2 means discharge. Now, what type of recommendation is going on? If it is G2B is recommending, then G2B will be 1, remaining all are zeros. If V2G is recommending, V2G is 0, 1, remaining all are 0. If discharging is recommending, discharging is 1, remaining all are 0. Like that, dummy coding will work. Previously, REC has the only one column has a different 0, 0, 1, 1, 2, 2 like that. Later, this 0 is converted as 1, 0, 0. This one is converted as 0, 1, 0. This 2 converted as 0, 0, 1. It is called as the dummy coding. This is the actual values. Okay. So actually, electricity price forecasting is called as a regression problem. So regression problem means if you are able to estimate, if you are able to predict, if you are able to forecast a particular variable value, if that value is a continuous number format, like your price may be continuous number, maybe 1000, 1200, 1500, 1700, any value. That's called a regression problem. And the classification problem means your output predicted value has a distinct values. Your predicted value is a distinct value. Like either the value will be 0, 0, 1 or 1, 0, 0 or 0, 1, 0. Only these 3 combinations will come into picture. Nothing will be coming. The discrete values are distinct values. That is called as the classification problem. In case of the regression problem, we are evaluating the customer model in terms of the mean square error or in terms of the mean absolute percentage error. Whereas in case of the classification problems, we are going to use the accuracy. Okay, we are going to use the accuracy. So we are going to use the accuracy as a performance metrics. You can see here the ANN model being developed by tuning the hyperparameters. As I said earlier, like hidden layer, hidden neurons, and accuracy functions, we are trying to get the optimal deep neural net model which has the highest accuracy. So accuracy should be high. If you say that a model is very good model, then your accuracy should be high and error should be as low as possible. Error should be low and accuracy should be very high. Error should be low and accuracy should be very high. So optimal model with high accuracy is selected for the real-time deployment. Optimal model with high accuracy is selected for the real-time deployment. Okay. The accuracy measures the proportion. So accuracy is nothing but how many samples are correctly classified out of all the samples. Out of all the samples. Let us assume my actual values are 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 1. Let us assume my predicted combination is like this 0, 1, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, and 0, 0, 1. Let us assume. Now this is the actual value, this is the predicted values. So what is the, how many, what are the total samples? 5, right? So divided by 5. What are the correctly classified samples? These are correctly classified. These are also correctly classified. These are also correctly classified. So that it's a 3 by 5 into 100. That means it is 60% accuracy. So that's how we can calculate the accuracy of any model. Accuracy of any model. Now, before going to wealth discussion on this, if you have any questions, please. Okay. Now the concept discussion or methodology discussion is completed. Now we will go for the results discussion. How we develop the optimal model. How we tune the type. So for this, we are using the Google Colab notebook. So this is the Python framework. Is used to run the codes, Python code. And by tuning the various hyperparameters like hidden layers, hidden neuron, and activation functions, we train the model. And our data is contains 69,985 samples. That means I have the 1, 2, 3, 4, 5, so on. 69,985 rows are there in my data set. 69,985 samples are there in my data. Row number 1, sample number 1, row number 2, sample number 2, like that. 69,985 samples is those number of samples are, those number of rows are available in my data set. So this table will represent the statistical information of your data. Statistical information of your data. Okay. Actually, my original data contains 72,960 samples, and based on the 80:20 ratio, for the training I got the 69,985, and remaining samples I am using for the testing. So first, what I did is, and one more thing, how we develop the architecture. How will be the architecture of the deep neural network model? Actually, in the deep neural network model, you have the 3 layers. One is called as the input layer, another is called as the hidden layer, another is called as the output layer. Okay. So in case of the input layer, the number of neurons in the input layer is equal to the number of input features. That means in the input layer, number of neurons are neuron 1, neuron 2, neuron 3, and so on. We have the total 98 neurons. Every neuron will take the some price values, and last 2 neurons will take the season information and the day status information. So number of neurons in the input layer is depending upon the number of input features. And number of neurons in the output layer is depending upon the number of variables you are trying to predict. So I'm trying to predict the load at next 15. That means now time is 3 o'clock, right? I'm trying to forecast the load at 3:15, only one value. So your output will be only 1 neuron. So this is called as your output layer, and this is called as your input layer. In between, you have the hidden layer. This is called as hidden layer because it is hidden by between, it is hidden between the input and output. That is called as hidden layer. So how many number of hidden layers we want to consider, and how many number of neurons in every hidden layer we want to consider, and what type of activation function we want to consider in the every hidden layer. So So those are called as the training hyperparameters. So first what I did is, so your input layer is fixed, your output layer is fixed. First we will take only one hidden layer. First we will take only one hidden layer and we randomly changes the number of hidden neurons. First we take the number of neurons in the hidden layer equal to 78 and we train the model and test the model based on the training data and testing data. And this blue thing represents the training error and this red line, red value represents the testing error. Okay, so first you have to initialize your model with 98 input neurons, one output neuron with 78 neurons in the hidden layer. Only one hidden layer first I consider. Now in the hidden layer, I consider the sigmoid activation function. Sigmoid activation function is mathematically modeled in the E 1 by 1 plus e power minus x. So sigmoid activation function will be like this. The values are varying from the 0 to 1. So minimum value is 0 and maximum value is 1. Varying from the 0 to 1. So when I include this sigmoid activation function in the hidden layer, when I consider the number of neurons in the hidden layer equal to 78, then my errors are 0.00093705 during the training, and this is my error during the testing. Same thing I repeated. Again, I rerun the code with the 98 neurons in the hidden layer, again 180 and 137 and 157 and 176 and 196. Randomly I have changed. Out of all these combinations, I am trying to identify which has the lowest testing error. So if you see lowest testing error, I think you can go with lowest testing error. Looks like this part here, 0.000977. But it is a 9 bit. It's a 9 bit. Okay. So as of now, I am considering sigmoid activation function with 196 neurons is the best model, but it's not fine. What I did next is, instead of sigmoid activation function, now I am using the tan hyperbolic activation function. So tan hyperbolic activation function is mathematically modeled like this. The z is the input and output will be e power z minus e power minus z divided by e power z plus e power minus z. Again, I changed the number of neurons in the layer as 78, 98, like that up to 196. And again, I have noted down. And I am trying to find the combination which gives the minimum testing error. If you observe here, the minimum testing error is here. It is less than when compared to sigmoid also. Sigmoid 0.0097, but here it is 0.0094. It's somewhat better when compared to sigmoid. Right? Similarly, I am going for the one more combination. Now I am taking the ReLU activation function. So ReLU activation function is mathematically modeled like this. If the input is negative value, the ReLU output is by default 0. If the input is positive value, ReLU output value equal to input value only. The input is 5, output also 5. Input is 10, output also 10. If the input is 20, output also 20. That's the ReLU activation function. With the ReLU activation function in the hidden layer, again I try with 78 neurons, 98 neurons, and 196 neurons like that. And also I'm trying to observe the training error and the testing error. Out of all those things, I'm trying to identify the model with the lowest testing error. Similarly, I tried with the Swift activation function also. These are everything for the load forecasting. These are everything for the load forecasting. So with the Swift activation function also, so we tried with the different number of hidden neurons, and we try to identify the model with the lowest error. So we have the different combinations. We have the sigmoid, we have the ReLU, we have the tan hyperbolic, we have the Swift activation function. Out of all these combinations, which combination gives the lowest testing error value that we considered as a optimal model as of now, not yet completed. So later what we did is, till now we changed the neurons and we changed the activation function. Now I am trying to change the number of layers also. Here we consider only one hidden layer, we only change the neurons. Now what I am trying to do is, now I am trying to layers also, number of layers. You can see here. Now I am taking the only one layer. This is the best I am getting. 0.0094 with Swift activation function. With Swift activation function, with only one layer, with with 94, with 196 neurons, I am getting the lowest error. So that's the best error. And now I am going with the 2 layers, I am going with the 3 layers, I am going with the 4 layers, I am going with the 5 layers, I am going with the 6 layers. When I am going with the 6 layers, you can see it is 945, it is a 940. So I am trying to identify this one as a best combination for me. That means a neural network model with 98 neurons in input layer, with 6 hidden layers, with 196 neurons in every hidden layer, and 1 neuron in the output layer, we identified as the optimal model because based on the performance in the testing. Based on the performance in the testing. Okay. So after that, batch size. What is this batch size? So batch size is nothing but, so let's assume we have the sample 1, we have the sample 2, we have the sample 3, we have the sample 4. Like that, we have the how many samples? 69,985 samples, right? Batch size equal to 1 means pass the sample 1, update the model parameters, your DNN model, update DNN. And later pass the second sample, update the DNN. Pass the third sample, update the DNN. That means batch size 1 means pass 1 sample next time, update the DNN. Suppose if I keep batch size equal to 2 means pass the 2 samples at a time, update the DNN. Later pass the next 2 samples at a time and update the DNN. So that is called as the batch size 2. Batch size 3 means pass the 3 samples at a time, update the DNN. And next 3 samples and update the DNN. So this process will be repeated. That's called batch size. Here also we tried with batch size also. First initially we tried with batch size 1. So these are the errors we are getting. And we tried with batch size 8, we tried with batch size 16, we tried with batch size 32, we tried with batch size 64. So among all the batch sizes, which gives the lowest value that we consider. This is the lowest value, batch size 64, we consider. So after that, sorry, it's the wrong this one. This is the upper parameter, not batch. This is the batch size. Okay. So this slide is not batch size, it is the optimized. So after 64 batch size, as of now, what is the final conclusion? There is a neural network with input layer 98 neurons with 6 hidden layers. Each hidden layer has the 196 neurons with Swiss activation function with batch size of 64. Okay. Now what I'm trying to do is with this combination, now I'm trying to change the optimization techniques. I'm trying to change the optimization techniques. Now I'm trying to go for the ADAM optimizer. I'm trying to go with the stochastic gradient optimizer. I'm going with the RMS prop. I'm going with the ADA delta. I'm going with ADA grad. Out of all those things, what based on my observation, so it looks like this one, 000965. That means ADA delta is performing better. So this is the final model that I want to use to deploy in the real time. So optimizer, what the optimizer, we get the best values, that is the ADA delta. That's the ADA delta. Okay. So that means final conclusion is we developed an optimal DNN model with 98 neurons in the input layer, with 6 hidden layers, with 196 neurons in every hidden layer, with 6 activation function. And output layer has the only 1 neuron with batch 64 with ADA optimizer. That model we consider as an optimal model, and we are going to deploy that optimal model into the backend of our application. Okay. Now these are the predictions. So with the testing data, my blue line represents the actual values, and my red line represents the predicted values by using this neural network model. So if you observe, almost your except very few cases, almost your predicted values are following your actual values. So predicted values are following your actual values. This is with the testing data set. And whereas in the training data set, with the training data set also you can see here, your blue line represents the actual and your red line represents the predicted value. So almost close to each other. Both actual values and predicted values. This is the curve based on the predictions coming from your optimal DNN model. Based on the optimal DNN model. Okay. Now, so this training data and testing data already available in the data set. So actually what we did is we kept some data aside. We are not using the data in the training, or we didn't use the data for testing. Also keep it separate. And with that separate data, with that isolated data we given to the our trained deep neural network model, and we verified what will be the predictions, what is the actual load available in that unseen data. So you can see this one. So this is my unseen data. Blue line is unseen actual data, and whereas your what's called your red line is a predicted by the neural network. Very small case, small deviation. That means very few cases there is some deviations are there. So I think so we don't expect exact the same values, and the same way it may not follow. So there is some deviation. The deviation will tell the error of your deep learning models. But in the most of the cases, it is able to follow your actual values, except a few cases like this. So this is the with unseen data. So these are with respect to the load forecasting we completed. With all this, with the load forecasting we completed. Okay. So what we did next is we are going for the another DNN model which is used for the recommendation, EV charging management or EV recommendation. Again the same process. Again the same process. What we did. So first, what will be the initial architecture? So for the second DNN model, what will be the initial architecture? Anyone? So as usual, in every deep neural network, we have the three layers. One is called as input layer, and is called as eddy layer, and is called as output layer, right? Anyone can tell me how many neurons will be there in the input layer? Based on my explanation, previous explanation for the load forecasting, how many number of neurons will be there for the input layer? Anyone? Based on our discussion for a DNN model for the recommendation. Second DNN model. First DNN model for the load forecasting. Second DNN model I want to develop now. So the DNN model contains how many number of neurons in the what's called input layer. Anyone, please? Anyone? You can use the chart box also if you want to communicate. How many number of neurons will be there in the input layer? At least how many number of in the data set that we are using to train and test the second DNN model for the charging strategy recommendations. How many number of input features are there? How many number of input features are there in the second data set? How many number of input features are there in the second data set? Which we discussed already. So how many number of input features are there? Price to mean ratio, battery level, present state, and next state. Four input features are there. So that in the second DNN we have the four neurons. One neuron is for the P by M ratio, another neuron for the battery level, another neuron for the present state, another neuron for the next. Tell me how many number of neurons will be in the output layer? How many number of neurons will be in the output layer? Again, go to data. In the output side, these all are the inputs. And the output side, how many columns are there? Three columns are there, right? So it will be three. It will be three neurons. It will be three neurons. Okay. So this is for the G2B. This is for the B2G. This is for the discharging. Suppose this neuron gives a high value 1, and if these are 0, 0, then this model recommending that G2B mode. If it is a 0, if it is a 1, then the model is recommending a B2G mode. If both are 0, if it is a 1, then the model is recommending a discharge mode. That's why 3 neurons. Now coming to the eddy layer, first we consider only single eddy layer with a different number of neurons. We go for the 3 number of neurons, 4 neurons, 5 neurons, 6 neurons, sorry, 7 neurons and the 8 neurons. Okay, so like that we are increasing, we are changing the number of neurons. So the single ED layer, sometimes initially we start with 3 neurons, at 4 neurons, with 5 neurons, like this we are increasing, and we train the model and also test the model, and we are noting down the accuracy, because the second ENN model is a recommendation, like a classification, whether it is going to classify if the G2B combination better, or the aim to classify B2G is better, or the aim to tell discharging is better. It is a 3 classes. It's a classification problem. So accuracy is our primary metric to evaluate the performance of the model. To evaluate the performance of a model. Okay. So that's why here 0.9981 is nothing but the 99.81% accuracy. Okay. So 9978 means it's the 99.78%. So you have to note down the accuracy values for every combination. Out of all the combinations, similarly what we did in the previous case, out of all the combinations, we have to do the best, which has a maximum accuracy. Previously, lowest error is the optimal. Now, maximum accuracy is the optimal. In the classification case, we have to go check for the maximum accuracy, which is close to 100%. Close to 100%, which is near to 100%. And whereas in case of the regression problem, we go for the lowest error. So going for the lowest error. So which is close to 0. Error should be low, accuracy should be high. So after these combinations, we are tried with the segment accuracy function initially with single ED layer, change the number of ED neurons like 3, 4, 5, 6, 7, 8, and we choose segment accuracy function. We run the model, train the model, test the model, and note down the best model based on the testing accuracy. Similarly, do with tan hyperbolic. Similarly, do with ReLU activation. Similarly, do with the Swiss activation function. Out of all these combinations, identify the model which gives the best accuracy or maximum accuracy. That model we consider as a optimal model. Okay. So here you can see here in this case, as of now, the DNN model with 5 single ED layer with 5 neurons with Swiss activation function has the maximum accuracy that is called 99.97%. 99.97%. Okay. Now till now what we did, we changed the hidden neurons and we changed the activation function. Now what we did is we tried to work with the change the hidden layers. So what you have to change? So what the final I think you are comfortable that so activation function is a Swiss and the number of neurons are 5. Now what you have to do is change the layers now. Take only one layer that's coming from this data 0.09981, 0.9981 and coming to here 0.997. So this combination is coming for a one layer. Similarly, train the model for the 2 layers, train the model for the 3 layers, train the model for the 4 layers, train the model for the 5 and 6 like that.
Sir, your voice is not audible, sir.
Madam?
Yes, sir. Audible, sir. Audible.
Okay. So you try with a different number of ED layers. If you observe here, so out of all, I think this is only the best combination. With single ED layer only, it's going better. So remaining all, it is lower value when compared to this combination. Remaining all are less value when compared to this combination. So I am stick with one hidden layer only with 5 hidden neurons with Swiss activation function. Later, what I did, I tried with different batch sizes. I choose the batch size 1, batch size 8, batch size 16, batch size 32, and batch size 64. Out of which 997, that means this one. Batch size 32, I am getting the best result. And optimizers now I tried. So I am trying the ADAM optimizer, GD optimizer, and RMS prop, and ADA delta, and ADA grade. Out of all these things, ADAM optimizer gave the best accuracy, that is called as 99.97. So finally, what is my conclusion? So I have a second DNN optimal model with one hidden layer, with 5 hidden neurons, with the Swiss activation function, with batch size of 8 with Adam optimizer is used to deploy into the as a real-time application. Deploy in the backend of your application. As an optimal model, we identify. As an optimal model, we identify this one. Okay. Now, generally, there is one thing is one parameter is called a confusion matrix. So the confusion matrix is used to observe the performance of any classification model. Any classification model. In our case, our DNN model is used for the classification, right? So now it is a DNN is our classification model. You can go with the same confusion matrix for the decision tree. You may go with the same confusion matrix for the random forest. You may go with the same confusion matrix for the SCC. You may go with the same confusion matrix for the CNN. Like any classification model, you can go with the confusion matrix. The confusion matrix will visualize you how accurate your model is. How accurate your model is. So what is this confusion matrix? So confusion matrix is drawn between your true values or true labels or actual values with respect to your predicted values. With respect to your predicted values. Okay. Now, what is this? You can see here 47,124 samples. So what it means is in 47,124 samples, actually these samples are suggesting zero recommendation, zero charging management recommendation. That means zero means G2B recommendation. Okay. Okay. Hope same 47,124 samples. Your model also predicted label. Your model also predicting zero. That means your model also suggesting that G2B. Okay. Actually, actual suggestion is for these 47,124 samples. Actual suggestion is going for the grid to vehicle mode, and your model also recommending same thing. That's good, right? That's good. So, and coming to this part, what is this one? So 7,621 samples suggesting that recommendation 1. Recommendation 1 means it's a V2G. And same 7,621 samples also recommending your model also predicting 1 only. That means is also V2G. What it means for 7,624 samples, these are the actually V2G recommendation. Your model also recommending V2G. That means that's also good. And coming to this part, 18,176. So that means your actually these are the recommendation 2. That means 18,176. The recommendation is G to B, grid to vehicle. And your model also predicting same. Your model also predicting same. You can see this is predicting and this is actual. So this model is predicting G2. That sounds good. So these diagonal elements are properly classified, properly recommended. But there is only one issue with respect to this 41 V2G samples. Actually, these 41 V2 samples are recommending 0. That means G2V. But your model is predicting as a V2G. Actually, it's a G2V, but your model is predicting as a V2G. So this is the wrong recommendation. That's why we are not getting the 100% accuracy. We are getting the 99.97%. How we calculate the accuracy? So accuracy equal to, sorry, I will write here. So accuracy equal to truly classified. What is the truly classified, truly recommended, perfectly recommended? So perfectly recommended are 47,124, 76,021, and 18,176. 18,176 divided by total samples. That means 47,124, 7621, and 18,176 plus 40 into 100. So this will give the value 99.97, but not 100% because there are 41 samples not recommended proper. So don't expect any model 100% accuracy. If we got 100%, very good, but don't expect every 100% of accuracy. Okay, 100% accuracy means so every time it is predicting correctly, accurately, without any problem. Real time is difficult. Real time, it is very difficult. So like this, like that, we can visualize the performance of any deep neural network model based on the confusion matrix. In the confusion matrix, these off-diagonal limits should be as values of the off-diagonal limits should be as low as possible. The values of the diagonal limit should be as more as possible. Then you can justify that your model is perfectly perfect. Perfectly perfect. Okay, this is the confusion matrix. Now, finally, after we deploy the model, we deploy both the DNN model for the load forecasting, another DNN model for the recommendation. So that means one DNN model, we are getting the giving the 98 input value, it gives the price value, and same DNN model we are using, and here also we are giving the 98 inputs, and but here we are getting the but this DNN model will help you to estimate the price for the 24 hours, 24 hours before. That means, let us assume I'm trying to give the recommendations to EV Warner for tomorrow. Then at 11:45 today, I am giving the prediction from the 12 a.m. to 11:45 p.m. tomorrow. Total 96 predictions are coming. So for all the 96 predictions, we are calculating the mean value. That mean value keeping here, and this price is coming here, and take the dividend. This is called as P by M ratio. Now took the second DNN model. And for this DNN model, you have to give the P by M ratio along with the P by M ratio coming from here. So along with the P by M ratio, you have to give few more things. One is the what is the present state, and what is the next state, and what is the battery level. So based on that, your second DNN model, what it will do? It will give the recommendation whether it is a 100 or it is a 010 or it is a 001. 100 means G2V. 010 means it is called as a V2G, and 001 means it is called as a discharging. It is called as a discharging. So three modes of operation. Now we did same thing. So for a whole day we tried from 00 midnight 12 o'clock to and next day up to 11:45 night. We are giving the complete recommendation to the owner. We are suggesting that so this is for the at midnight, it is for the vehicle to grid mode, and from this port to this port, it is a blue level grid to vehicle mode, and again from here to here, it is again V2G mode, and from here to here, it is a discharging mode, and like this, we are giving the complete recommendations for the whole day we are providing. So we can like that. So we are recommending our deep neural network architecture. This complete whole methodology is recommending what type of charging strategy we are going for. Whether you are going for the G2B or you are going for the V2G or you are going for the discharging mode. So this blue will be the V2G recommendation. Orange will be the blue will be the G2B recommendation. Orange will be the V2G recommendation, and this green will be the discharging recommendation. Okay, and as I said earlier, so if we build some model, so we have to compare with other models to validate, to check the superiority of your model, to validate your model or to check the superiority of your model. So we are our load forecasting DNN model. We try to. This is for the regression problem. This is for the classification. Because in the regression, it is shown in terms of the losses, mean square error. Whereas in case of the classification, it is measured in terms of the accuracy. Performance is validated in terms of the accuracy for the classification model, and where performance is observed for regression models in terms of the mean square error. In terms of the mean square error. Okay. Now, so this is our ANN model or DNN model, what we are using, and we are comparing with the linear regression, random forest, descending SVR, and when compared to all the things, we are getting the better testing performance with the ANN. And similar in the case of the classification also, I tried the proposed model with the linear support vector classifier. So my model has the 99.97% of accuracy, but this one gives the 84.87% accuracy. So this is how we have to do our. And coming to the conclusion. So in the conclusion, that means our presentation, we do the EV charging management with the deep learning techniques based on the electricity price. So we are trying to recommend by using the deep neural network model. So based on the battery level, based on the present state, based on the next state, and based on the TBF ratio. Okay, and this work can be further extended. That recommendation of the charging strategy extended based on the grid stability and also based on the reinforcement learning. So if you're able to apply the reinforcement learning, this may become a good one. Of course, many already researchers are start working with reinforcement learning for the recommendation for the EV charging. So, but you can try with some other modifications. So this is about the whole presentation in my face. Okay, and just a minute. Now I want to show slightly implementation of our code also, but just give some idea how we are doing all the things. 1 minute. Yeah. No, not this one. So give me some. Give me time. So my hit before it is the EV scheduling. So I just we have 15 more minutes. Just I'm trying to go with that load forecasting DNN model. How we try. Okay. So this time trying to give some idea. Maybe you can many materials are available in the online to understand this code, but I will try to explain. So these are first line of code to integrate my Google Colab or to make a connection between my Google Colab and my Google Drive. Why I am trying to create a link between my Google Colab and Google Drive is my whole data, both training and test data for the price forecasting and DNA recommendation are kept in my drive. I want to take the data from my drive. So for that purpose only, I am using this mount drive dot mount. This piece of code I am using. Suppose if you don't have a data in your Google Drive, then you no need to do this part. If you don't have a data in your Google Drive, don't do this part. Okay. Now there's a few libraries which are required to build the deep neural network model are available here. Now in this cell, what I'm doing is actually in this path in my Google Drive in EV scheduling folder. This is the my data set name. In the CSV format, I stored my data set. Now from this path, I want to take the data and I want to store the data with the name of a variable called data. And that data information is available here. So you can see here, total 96 features and one season feature and one day status feature. So 96 plus 97 and 99 and the last column that is called as the target column that is called as the price. Okay. Now we can go for the data description to give the some statistical information. And I said that we are going for the data normalization. So in Python, there is a library called minimax scalar. This scalar will help to normalize the data. So normalization of data is nothing but we are connecting the data between the 0 to 1. Actually, if you observe the data, all the values are in terms of the thousands, right? But after normalization, if you observe the data are in between the 0 and 1. After normalization, the data is in between the 0 and 1. So this is called this is how we can do the data normalization by using the min-max scalar method. Later, so as I said earlier, whatever the data we have, we are trying to split the data. Okay, so this is the piece of code we are using to split the data. In the library, in the Python, we have a library called train_test_split method. Train_test_split method. Based on this method, you can split the data for the training purpose and also for the testing purpose. Maybe you have a doubt. So training, why there is two variables for the training. So xtrain holds the input features of a training data. Ytrain holds the target variable values of the training data. Similarly, X-test holds the input data. X-test holds the input data of a test, input features of a test data, and Y-test holds the target variable of a test data. Okay, and here we have to pass the input features of the whole data, output target variable of the whole data. Here train size 0.2, test size 0.2, nothing but out of all data set, I want to use the 80% of data, that is called 0.8 for the training purpose and 0.2, that is 20% data for the testing purpose. So this is the line you can use to split the data. So once the data splitting is over, now we are going for the model development. So for the model development, you can see there is a Keras called deep learning framework. So we are using the Keras deep learning framework. From the Keras, you have to import sequential models, dense layers, and also you can import different type of the optimizers. As I said in the previous slides, we have to train our deep learning model with various types of optimization techniques: RDA, FGD, RD delta, and RMS. So all the libraries we are going to import. We are going to import from the Keras deep learning framework. Once we are importing all the Keras deep learning framework libraries to build the deep neural network model, now you can build the deep neural network model like this. You can see model equals sequential. This is the default value. So now I want to add one layer, model.add dense 78 neurons in the hidden layer, because you can see our presentation. Yeah, you can see 78 neurons. So I want to keep the 78 neurons. So here my intention is, see how many hidden layers are there? 1, 2, 3, 4, 5, 6 hidden layers are there. 6 hidden layers, and every hidden layer has a 78 neurons. And what is the activation function? ReLU activation function. Like that, we can build your deep neural network model. So 78 neurons in every hidden layer, and ReLU activation function in every hidden layer, and total number of hidden layers are 1, 2, 3, 4, 5, 6 hidden layers. Whereas for the first hidden layer, what is the input? For first hidden layer, input is coming from the 98 neurons. 98 neurons because 96 price samples and one season sample and one day sample. One day sample. That's why to the 98. This is the after input layer, after hidden layers. Last layer is called as the output layer. In the output layer, you have the one neuron, and activation function we are considering sigmoid activation function. Okay, so this is how we can build our deep neural network model. Okay, suppose if you want to build a deep neural network model with only 2D layers, then what we do? We only keep these two and remove these four. Remove these four. If you remove these four, you have this is the one hidden layer, this is another only 2 hidden layers. Like that, you can change. If you want to change the active function in place of ReLO, you can write SIGMOID, sigmoid. You can write TANH. You can write swish. What active function you can use? You can use that active function. Like here, I'm writing sigmoid. Like you can here also you can keep sigmoid. If you want to use sigmoid activation function in the layers. If you want to use the TANH, write the TANH. If you want to use the swish, write like later. So here we have to do the model. So model building is completed. Now you are going to compile. So for compile, you have to tell. So what metrics you want to use, what loss function you want to use, what optimizer you want to use. So here I want to use the loss function mean absolute percentage error, metrics of mean absolute percentage error, whereas the optimizer is the Adam optimizer. You can change, you can edit all the things based on your requirement. If you want the MSE, if you want to use MSE, keep MSE here, keep MSE here. If you want to use the ADA grad, write ADA grad here. You can edit these codes. What activation function you want, what optimizer you want to use, what error metrics you want to use, what loss function you want to use. Later, I want to train the model. Later, I want to train the model. So train the model is nothing but the model dot fit. You have to pass the training input and the training output. Previously, I said that different batch size 1, batch size 8, batch 16. So you can change the value here. Here I am using the batch size 32. Okay. So epoch means how many number of iterations you want to run this. You want to train the model. How many number of iterations you want to train the model. That is called as epoch. Okay, how many models you want to, how many iterations you want to train the model. So that is called as epochs. Here we consider the number of epochs equal to, here we call the number of epochs equal to number of epochs equal to 10 I have considered, but you can consider different values you can consider. You can verbose means 0, 1, 2, you can give 0, you can give 0, you can give 1, you can give 2. That will represent how you want to display this information. How you want to display this information. How you want to display this information. Okay. Now, if you want to test the model, you can use the model.evaluate. If you want to test the model, you can use the model.evaluate. So in this case, you can pass the X test, you can pass the Y test, and also you can pass the. So you can give the losses are 7.417. Here given the mean average is the 7.4. So like that, you can build the deep neural network model, and also you can train the model, you can test the model, you can observe the losses, all the things, and use this type of thing. Same code we similarly we can try for the EVCM. So this code is used to build the deep neural network model for the recommendation. PM, raised to mean ratio, BL, battery level, present state, next state, and recommendation. So this recommendation is later split into 3 columns based on the dummy coding. Again, same thing again. So train text fit methods with the data. And this is the loss and accuracy values. And this is the train the model. And this is the compile the model. This is the build the model. And this is the fit the data. So like that, because actually generally I use the 5 days workshops like that to explain the neural networks. So it's not possible to explain in detail about code. That's why just I'm giving you some idea how I can write the code for the neural networks in deep learning. Just give me 1 minute, please. If you have, so this is from my end. If you have any questions, please. So please let me know if you have any questions, please. So this is from my side actually. Praveen.
Hello, sir.
Madam.
Any questions from participants? You can ask in the chat box or directly.
So implementation of any model, machine learning or deep learning, is easy because many sources are available in the online. But whenever just I'm suggesting, because no one is asking anything, just I'm suggesting. If anyone wants to learn some models and want to apply, so try to learn from the basics, try to understand from the back-end mathematics, and try to write your own code and for a small application. Then you can understand how it will work. Later, you can go for the bigger application. When you are going for the bigger application, then go for the libraries and toolboxes. Because when you write your own code for small applications, you are able to understand what happened behind. If you directly go for the toolboxes or the libraries, so it's like a black box. We are feeding the data, we are getting the output. We don't know what happened there. Okay.
Any other questions? Okay. Now it's time for vote of thanks. Respected participants, esteemed speakers, and dedicated organizers. As we conclude this enriching faculty development program, it is my honor to extend a heartfelt vote of thanks on behalf of everyone involved. First and foremost, I would like to express our profound gratitude to our distinguished speakers for sharing their invaluable insights and expertise. Your presentations have inspired us and provided practical strategies that we can implement in our teaching practices. A special thank you to the organizing committee whose tireless efforts ensured the smooth execution of this program. Your meticulous planning and attention to detail made this event a resounding success. I would also like to acknowledge the enthusiastic participation of all faculty members. Your engagement and willingness to learn have contributed greatly to the program's vibrancy and success. Finally, let us carry forward the knowledge and connections we have gained here. Together, we can continue to enhance our teaching and create a positive impact on our students. Thank you once again for your time, dedication, and commitment to professional growth. We look forward to seeing you in future sessions. Thank you, sir. Thank you for accepting. Thank you for accepting our invitation for valuable suggestions. Thank you so much, sir.
Thank you.
Feedback will share in a chat box. You can fill it now. Thank you, one and all. Thank you. Certificates will be issued in this week mostly. We'll send in a WhatsApp group or through mails. Thank you.